Hello friends, today we will discuss about close packing in solids. In one-dimensional solids, there is only one way of arranging spheres. These spheres represent constituent particles like atoms, ions or molecules. Now what is Cn? Cn means coordination number. Coordination number is the number of nearest neighbors of a particle. Like this particle has two nearest neighbors. First neighbor is this particle and the second neighbor is this particle. So this particle has two nearest neighbors. So the coordination number of this particle is 2. In two-dimensional solids, first is square close packing. In square close packing, there is only one type of row. One row is arranged after another. While arranging these constituent particles, some empty space is left between these particles. This empty space is called voids. These voids look like square. That's why they are called square voids. Second is hexagonal close packing. In hexagonal close packing, there are two types of rows. First one is this kind and second one is this kind of rows. Now, in hexagonal close packing, the voids look like triangle. That's why they are called triangular voids. Now we will talk about coordination number. In square close packing, this particle has four nearest neighbors. First particle is this, second particle is this, third is this and fourth is this. So this particle has four nearest neighbors. So the coordination number of this particle is 4. In hexagonal close packing, this particle has 6 nearest neighbors. 1, 2, 3, 4, 5, 6. So the coordination number of this particle is 6. In three-dimensional solids, we will study first of all from 2D square close packing. In this kind of packing, second layer is placed above first square layer. Like this is the first layer, after this there will be a second layer, then third layer. Below this layer there will be another so many layers. There are only one type of layers, that is A. The voids which are formed in this kind of packing are known as cubical voids. Now we will see from 2D hexagonal close packing in three-dimensional solids. In this packing, spheres of second layer are arranged in depression of first layer. There are two type of layers. So the spheres of second layer, spheres means constituent particles of second layers, are arranged in the depression of first layer. Like this is like this kind of structure. This is the depression. So the particles are arranged in the depression of first layer. The voids which are formed in this kind of packing are known as tetrahedral void and octahedral voids. Covering tetrahedral voids. In tetrahedral voids, third layer is exactly aligned by the first layer. Like this is the first layer, this is second layer and this is third layer. Here we can see that the third layer is exactly aligned by the first layer. The structure which is formed is known as hexagonal closed packed structure. Coordination number is equal to 12 and the atoms per unit cell in hexagonal closed packed structure is equal to 6. The AB pattern is formed in this kind of voids. Example are zinc, magnesium, beryllium, etc. In octahedral void, spheres of fourth layer are aligned with those of first layer. The constant particles of fourth layer are aligned with the constant particles of first layer. The structure which is formed is known as closed packed structure, CCP or FCC. FCC means face centered cubic structure and the coordination number is equal to 12 and the atoms per unit cell in this kind of structure is equal to 4. The pattern which is formed is ABC, ABC. Examples are copper, nickel, silver, gold, etc. In face-centered cubic and cubic closed packed structures, if the total number of atoms per unit cell is equal to n, then the total number of octahedral void per unit cell will also be equal to n, and the total number of tetrahedral void per unit cell will be equal to 2n, and the total number of voids will be equal to 3n. The coordination number of triangular void is 3 and the coordination number of tetrahedral void is 4. See, there are 4 particles around this void. The coordination number of octahedral void is 6 and the coordination number of cubical void is 8. Now what is packing efficiency? Packing efficiency is the percentage of total space covered by constituent particles. So what is packing efficiency? Packing efficiency is the percentage of total space which is covered by the constituent particles. Now we can find the packing efficiency with the help of a formula, and the formula is volume occupied by the atoms divided by the total volume of the unit cell into 100. If you want to find the packing fraction, then the formula is volume occupied by the atoms divided by total volume of the unit cell. Now there are some crystal system whose packing efficiency is given. simple cubic system has the packing efficiency 52.4%. BCC. It means body-centered cubic system has 68% packing efficiency. Face-centered cubic or cubic close packed structure has 74% packing efficiency. In the same way, hexagonal closed packed structure also has 74% packing efficiency. You can find the void percentage with the help of a formula, that is 100 minus packing efficiency. If we subtract the packing efficiency from the 100, then we will get the void percentage. Now we will see some unit cells. In simple cubic unit cell, atoms per unit cell is equal to 1. In face-centered cubic structure, Z is equal to 4. And in body-centered cubic structure, atoms per unit cell is equal to 2. Now distance between nearest neighbor. Like in simple cubic, distance between nearest neighbor is equal to A, like this. This is the structure of simple cubic. And the distance between nearest neighbor is A. In face-centered cubic structure, distance between nearest neighbor is A by under root 2. And in body-centered cubic structure, D is equal to under root 3 by 2A. Now radius. The radius of simple cubic structure is A by 2. And in face-centered cubic structure, A by 2 under root 2. And in body-centered cubic structure, radius is under root 3 by 4A. The coordination number in simple cubic structure is 6. In face-centered cubic structure is 12 and in body-centered cubic structure is 8. Now we will see how to find the packing efficiency. The formula of packing efficiency is volume occupied by the atoms. And what is the shape of atoms? The shape of the atoms is spherical. So the volume of sphere is 4 by 3 pi r cube, right? So the formula for packing efficiency is Z into 4 by 3 pi r cube divided by A cube. A cube represents total volume of the unit cell into 100. Z represents total number of atoms per unit cell. Now, if we want to find the packing efficiency of simple cubic system. In simple cubic system, the value of Z is equal to 1. The value of Z is 1. Atoms per unit cell in simple cubic system is 1. So we will put 1 in place of Z into 4 by 3 pi r cube. Now, how will we find the value of A? We know that in simple cubic system, the radius is equal to A by 2. Radius is equal to A by 2. So from here we can conclude that A is equal to 2R. In place of A we will put 2R. And if we solve this, we will get 4 pi R cube divided by 3 into 8 R cube into 100. R cube will be cancelled and we will get packing efficiency is equal to pi by 6 into 100. This is the packing efficiency. And if we solve this further, we will get the packing efficiency of simple cubic system is 52.4%. Now, this is the packing fraction of simple cubic system, right? So the packing fraction of the simple cubic system is pi by 6. Now, if you want to find the void percentage of the simple cubic system, then to find the void percentage, we will simply subtract the packing efficiency from 100. The packing efficiency of simple cubic system is 52.4%. So from 100 we will subtract the 52.4% and we will get the void percentage is equal to 47.6%, right? Now if we want to find the density of a system, then how will we find the density of any unit cell? To find the density of unit cell, the formula is given Z into M divided by Na into A cube. Z means atoms per unit cell. M represents molar mass. Na is Avogadro number, which is equal to 6.022 into 10 to the power 23. This is the constant. And A is edge length of unit cell. For example, if edge length of unit cell is given 408.6 into 10 to the power minus 10 centimeter and molar mass is given 107 gram per mole, and the structure is cubic close packed structure, and in cubic close packed structure atoms per unit cell is equal to 4. So we can simply apply the formula and we can find the density of a unit cell. Now we will see radius ratio. Radius ratio is equal to ratio of cation divided by ratio of anion, and here the radius ratio of some structures